Okay, guys, this is Rafael Danero from the Java Challengers, and today we're going to see a special challenger about data structure and stack. So let's analyze how we define a stack with Java, and then we're going to see some unit tests. So let's see the code then. Okay, so that's the stack challenger. As you can see here, we are passing a generic type, which will contain our data. And here is our stack pointer that will be basically the index from our array. And on the constructor, we are initializing our array with a size of 500. And then we are just converting to the generic type that was defined in our class. And we are also just initializing the stack pointer with 0. And as you can see here on the push method, we are basically assigning a new element. And when we assign a new element, then we would be incrementing the stack pointer variable. So on the pop method, we would be removing the element from the top of the stack. And here we would be just asking if the element is contained into the stack, and the access method would be responsible for just accessing the element inside the stack. And here on the size is just the size of the whole stack. So the data structure stack is we use the LIFO strategy. So it's the last in, first out. So we can think of a stack like a deck of cards. So if we put a card on the top of the stack, and if we remove the card on the top of the stack, we would be using the methods push that would put an element on the top, and the pop that would be removing the first element. Okay, so yeah, the stack data structure is not good for accessing elements, for example, because we would have to run through all elements, and that would be really slow. So that's the stack program. And then there are some unit tests that I'm gonna ask you what is the output, if it passes or not. So I'm gonna just open the test. Okay, so that's the first test. So what do you think? It's gonna pass or not?
I would say this would pass the test.
Okay, and what about you, Derval? Do you think it's gonna pass? So that's the Podio here, the Simpson character. So we are also using Lombok, and this annotation means that we have a constructor that all the arguments are being passed. So yeah, that's it. Do you think it's gonna pass?
Yes, it is gonna pass.
Okay, let's see the answer then. Ta-da-da. Oh man.
Oh.
Fail.
Oh.
Yeah, Derval. So yeah, you were talking about equals and hash code. It doesn't have the equals hash code, so that's why it's gonna break. So it's because on the contains method, we basically go through all the elements, and then we ask if the element from the array is equals to the other. But as we don't have the Simpson character equals and hash code method implemented here, it will break.
But Lombok is implementing, I think.
So
Let's see. Oh
it's
no!
not?
When you put data, all the methods are created. I was thinking about the data annotation.
Yeah, but we didn't use the data annotation here.
All right, so it would not pass. Very good.
Yeah, so basically the push method and the contains methods are fine, but as we didn't have the equals and hash code implemented on the Simpson character, then it will break.
I was catched by Lombok today.
Yeah, so that's the second test. So on this test, we are testing, so when we pop the items, then check if the items were removed. So here we are inserting 3 Simpson characters. And as you can see here, Mr. Burns is 135 years old. So he's a very young guy. And here we are popping 2 elements. And as you remember, iStack used the strategy LIFO. So this means that it's last in, first out. So basically, we insert the elements on the top of the stack, and when we use the pop method, we remove the elements on the top of the stack as well. So by knowing that, do you think this test is going to pass or not?
This will fail.
Let's see more carefully. It will pass.
Okay, then, so are you ready to see the answer?
Yes.
Okay, let's go.
Okay, so let's see that. Ta-da-da-da. It failed.
Yeah. At least one right.
Oh, congratulations, Farah.
Okay, so I'll explain why it failed. So we have to remember that the stack data structure use the strategy LIFO. So this means that it will insert elements on the top and it will remove elements from the top as well. So here we are pushing Krusty and then Simpson character Homer and then Burns.
Yes.
And
Burns in the top. Is that
Burns
right?
is on the top. Yeah, that's
On
it.
the
Yeah.
top. Then the pop will remove it first.
Exactly. So yeah, that is tricky. It's because the push method is like a deck of cards. So let's imagine we have a deck of cards here.
Yes.
And we are always putting the elements one on the top of the other, one card on the top of the other. And then, for example, if we put the card of Krusty, and then if we put the card of Homer, Homer would go on the top of Krusty. And if we put the card of Burns, Burns would go on the top of Homer. So yeah, Burns would be the first, Homer the second, and Krusty the third. And the pop method will remove the first element on the stack and the second element on the stack. So it will always remove the element that is on the top. Removes the element that is on the top of the stack. So yeah, that's why in the end we're gonna have only Krusty.
It's very tricky.
It is.
Very good challenge.
Thanks. Okay, guys, so the main key points of this challenger is to remember that a stack will insert the elements one on the top of the other. So for example, on our challenger here, when we inserted Krusty and then Homer and then Burns, when we insert Krusty, Krusty would be the first element. And then when we insert Homer, then Homer is the first element and Krusty is the second. And when we insert Burns, then Burns would be the first, and Homer would be the second, and Krusty would be the third. And then the pop method will remove the first element, always the element that is on the top. That would be, in this case, Burns and then Homer. And then that's why we just have Krusty in the end. And also remember that stack is not effective for accessing elements or going through all the elements. This wouldn't be effective. But if you want to deal with operations like that, I mean, to push an element to the top always, and then to remove the first element of this stack, then it would be a great option for your data structure. Okay, so I'm just gonna stop sharing my screen here. Okay, guys, so today you saw a challenger that was a bit different from the others. So that was about the data structure of stack. And it's important to at least know them because you will have to decide what is the best data structure for your project. And then if you have this knowledge, it will be really handy. And that's it. I'm going to leave you the code link so you can get the code. It's on javachallengers.com/code. And then you can just run your own tests and really absorb the concepts. And that's it for this challenger. If you like the video, please give a like and get subscribed to the channel, because in that way, you're going to be helping me out to produce even better videos for you. And that's pretty much it for this challenger, and see you the next time.